Welcome back to the deep dive. Today we're jumping into a really core Java feature enumerations. They look simple, maybe you use them all the time, but for senior interviews, there's a lot under the hood they expect you to know. So if you're prepping for that next big interview or just want to really solidify your Java fundamentals, this is for you. Our mission, make you an Enum expert, ready to handle those tricky questions.
Exactly. Enums seem basic, but they pack a punch. They're not just constants. They're proper types with features interviewers love to ask about. We'll go way beyond just listing values. We'll cover the basics, yeah, but also the built-in methods, how to add data, add behavior, even different behavior for each constant initialization gotchas, and using them with switch. All with an eye on nailing those interview discussions.
Okay, let's dive right in then. What is an enum fundamentally in Java?
At its core, it's a special kind of class. Its main job is to represent a fixed, unchangeable set of named constants. Think finite list, like days of the week or planets. Fixed set and type are the key ideas.
Got it. Fixed set. So let's use a common example, maybe clothing sizes. How would you declare that?
Yeah.
Use the enum keyword, right? Something like create a public enumeration named size with 4 constants. Small, medium, large, and extra large.
Perfect. And the big advantage here, compared to, say, just using int constants like 0, 1, 2, or string constants, is type safety. Because size is its own type, the compiler knows that only small, medium, large, and extra large are valid. You literally can't pass a random integer or a misspelled string like Lars, where a size is expected.
Ah, okay. It's like ordering from a menu. You pick small, medium, whatever's listed.
Yeah.
You can't just invent a size sorted medium. The compiler stops you.
Exactly. Compile time safety, preventing runtime bugs. It's a huge win.
So if size.small and size.medium are these unique fixed things, instances, really,
Yeah.
How do you compare them? This feels like prime interview territory.
It absolutely is. And the answer is simpler than you might think. Because the Java language specification guarantees that there's only one instance object for each enum constant, like size.small, is always the exact same object you use the double equals operator.
Yep, double equal.
It checks for object identity are these 2 references pointing to the exact same object in memory. And for enums, they will be if the constants are the same. Now, you could technically use the dot equals method enums inherit it, but the default implementation for dot equals in java.line enum just does a double equals check anyway.
Oh, yeah.
So using double equals is more direct, slightly more efficient, and it's the idiomatic preferred way.
Right. So interview question 1 pops up. How do you compare enum values and why?
Your answer, use double equals. And the why is crucial because enum constants are guaranteed singletons, so correctly checks if they are the same constant by comparing object identity.
Mm.
And maybe add a tip. Mentioning that dot equals also works, but just delegates to shows extra understanding.
Got it. Double equals for identity. Okay, moving on. What about built-in helpers? How do I get the name of a constant like small back as a string?
Easy peasy. Every enum constant has 2 methods for this. toString and name. Both medium.toString and medium.name will return the string medium.
Any different?
The name method is declared final, so you can't overwrite it. toString can be overridden if you wanted a different string representation for some reason, but usually you just want the declared name, so either works.name guarantees the exact declared name.
Okay. What about going the other way? I have the string large, maybe from user input or a config file. How do I get the actual size.large object?
For that, every enum type gets a static method added automatically by the compiler called valueOf. You call it on the enum class itself, so you'd write something like create a variable named not my size of type size, and assign it the result of calling the static valueOf method on size with the string parameter small.
Size.valueOf with the string. Got it.
Important point though, valueOf is strict. The string you pass must match one of the declared constant names exactly, case sensitive and all. Small won't work, only small.
Ah, okay. Which leads perfectly into interview question 2. What happens when you call valueOf with an invalid string? Like if someone passed extra small.
It doesn't return null or anything gentle. It throws an illegal argument exception.
Ouch.
Yeah. So in an interview, name that specific exception, illegal argument exception. And a good tip is to mention how you'd handle it in real code. Probably wrap the valueOf call in a try-catch block, or maybe validate the input string first against the known values if it's coming from an unreliable source.
Good tip. Avoid those runtime explosions. Okay, so how do we get that list of known valid values to check against?
Another automatically generated static method values. When you call size.values, it returns an array like this. Create an array variable named all values of type size array and assign it the result of calling the static values method on size.
And that array contains size.small, size.medium, size.large, size.extralarge,
Yeah.
in that order.
Exactly. In the order they are declared in the enum definition.
Super useful. You could loop through that array easily. For example, create an enhanced for loop that iterates over each size in the result of calling size.values. For each size s, call system.out.println with parameter s, and bam, you've printed all the sizes.
Precisely. Very common pattern for iterating over all possibilities.
You mentioned declaration order again. Is there a way to get, like, the numerical position, the index?
Yes, there is. It's the ordinal method. It returns an int representing the zero-based position in the declaration. So if you call the ordinal method on size.medium...
That would return 1 because small is 0, medium is 1.
Correct. Small is 0, medium is 1, large is 2, extra large is 3. But here comes a big warning sign, and definitely something interviewers might probe. Relying on ordinal values directly in your logic is generally considered bad practice. It's brittle.
Brittle how?
Imagine you decide later to add a medium-large size between medium and large, or maybe just reorder them alphabetically. Suddenly, the ordinals for large and extra large change. Your code that assumed large was ordinal 2 might now break, or worse, do the wrong thing silently.
Ah, I see. The number itself has no real meaning, just the position, which can change.
Exactly. The ordinal value lacks semantic meaning. If you need to associate a specific number or code or abbreviation with an enum constant, you should explicitly add a custom field to the enum yourself. Don't rely on the fragile declaration order.
Which sets up interview question 5. What's the difference between ordinal and custom fields?
The key difference is stability and meaning. Ordinal gives the declaration position zero-based, which can change unexpectedly. Custom fields are values you define and control for each constant, giving them stable, meaningful data. Always prefer custom fields for anything beyond simple internal ordering.
Makes sense. And you mentioned ordering. How does sorting work? Do enums implement comparable?
They do, automatically. Every enum type E implements comparable parameterized with type E, and guess what the default comparison logic is based on?
Uh-oh. Let me guess. Ordinal.
Bingo. The default compare_to method compares enum constants based purely on their ordinal values. The signature looks like int compare_to method with parameter other of type enum with generic type parameter E.
So, interview question 6. How do enums implement comparable?
They automatically implement comparable using the ordinal value for comparison. Tip. Add that while it's automatic, relying on this ordinal-based comparison is less common than using enum for equality, or maybe a custom comparator if you needed to sort based on, say, a custom field you added.
Okay, this custom field idea is interesting. You're saying enums aren't just lists of names. They can hold actual data and have methods, like real objects.
Precisely. This is where they get really powerful. You can give them instance variables, constructors, and methods, just like a regular class, but still retaining that fixed set of instances.
How does that work? Let's say we want our size enum to have an abbreviation, like S for small, M for medium, etc.
Okay, you'd modify the enum definition. First, you declare the constants, but now you pass the data they need to their constructor right there. So it looks like this. Create a public enumeration named size. Define 4 constants. Small with parameter S, medium with parameter M, large with L, and extra large with XL.
Okay, passing arguments, like calling a constructor.
Exactly. And then after the list of constants, you must put a semicolon. That semicolon separates the constant list from the regular class body members that follow.
The semicolon is key.
Yes. After the semicolon, you define the members. Add a private instance variable named abbreviation of type string. Create a constructor that takes a string parameter named abbreviation and assigns it to this dot abbreviation. Add a public method named getAbbreviation that returns a string and returns the abbreviation field.
So when does that constructor run?
It runs once for each constant when the enum class is first loaded by the Java virtual machine. Small s calls the constructor with s, medium M calls it with m, and so on. Each constant is constructed exactly once, making them singletons.
And you made the constructor private in the example.
Mm-hmm.
Wait, can enum constructors not be public? This sounds like interview question 3. Why are enum constructors always private?
That's a classic. And yes, they cannot be public or protected. They're effectively private by default, even if you don't write the private keyword.
Yeah.
You can explicitly write private, but you can't make them more accessible.
Why not?
It goes back to the fundamental definition. An enum has a fixed set of instances. If you could call the constructor from anywhere using new size, you could create new arbitrary instances of size, breaking the whole point of having a predefined limited set. Making the constructor inaccessible from outside ensures that only the constants declared within the enum body itself can ever exist.
Gotcha. It locks down the instance creation to only what's defined inside the enum itself. Enforces the fixed set.
Precisely. And then as you saw, you just add normal methods like get abbreviation to expose the data or add behavior related to that data.
Okay, so all constants can share the same fields and methods. But what if you want different behavior? Like an operation enum where ADD actually adds and subtract actually subtracts. Can each constant do its own thing?
Yes. And this is probably one of the coolest, most object-oriented features of enums. You can provide specific method implementations directly within the constants declaration. It uses a concept similar to anonymous inner classes.
Well, okay. How does that look? Let's do that operation example.
Right. You start by declaring the constants, but you follow each one with curly braces containing the specific method implementation for that constant. It would look something like this. Create a public enumeration named operation. Define ADD with a body that overrides the public method evil, taking two int parameters, arg1 and arg2, returning arg1 plus arg2. Define subtract with a body that overrides evil, returning arg1 minus arg2. Define multiply with a body that overrides evil, returning arg1 times arg2. Define divide with a body that overrides evil, returning arg1 divided by arg2.
Okay, so each constant has its own evil implementation.
Exactly. And then after the constants and the required semicolon, you declare the method signature that they are all implementing. Often you make this method abstract in the main enum body if every constant must provide its own version. So after the constants, declare an abstract public method named evil that takes two int parameters, arg1 and arg2, and returns an int.
Abstract method forces every constant to implement it.
Yeah. Yep. It ensures completeness, though you could provide a default implementation in the main body if that made sense, and then only override it for specific constants.
And using it is just like calling a normal method.
Totally. You get an operation instance, say op, and just call op.evil xy. Java's polymorphism handles routing the call to the correct implementation based on which constant op actually is. So you'd write, create a variable named op of type operation and assign it some value like operation.multiply. Create an int variable named result and assign it the result of calling evil on op with parameters first and second. Result gets first, second.
That is really powerful. It bundles the operation type and the operation logic together.
Exactly. Under the covers, ADD is like an instance of an anonymous subclass of operation that implements evil one way, subtract is another subclass implementing it differently, and so on.
Okay, hitting interview question 7. Can you add methods to individual enum instances?
The answer is a clear yes. You explain the mechanism, declare the method in the main enum body, often abstract, and then provide the specific implementation within curly braces right after the constant name in its declaration. And for a tip, mention this is great for state-specific logic or implementing patterns like the strategy or command pattern in a really clean, type-safe way.
Switching gears a bit, can enums have static stuff? Static variables, static methods, static initializer blocks?
They sure can, just like regular classes, but there's a potentially tricky interaction with the initialization order. This trips people up.
Uh-oh. What's the catch?
Remember how the enum constants are constructed first when the class logs? Well, static variables and static initializer blocks run after all the constants have been fully constructed.
Okay, yeah.
So you cannot reliably access a static variable from within an enum constructor, because when the constructor for, say, the first enum constant runs, the static variable might not have its final value yet, or worse, might not even be initialized.
That could lead to weird bugs or even errors. Can you show an example of what not to do?
Sure. Imagine a modifier enum for code modifiers, and you want to assign each one a unique bitmask value using a static counter. A naive, wrong approach might be: create a public enumeration named modifier with constants public, private, protected, static, final, and abstract. Add a private static int variable named maskBit and assign it 1. Add a private instance variable named mask. Create a constructor that takes no parameters. Inside the constructor, assign maskBit to the instance variable mask, then multiply maskBit by 2 and assign it back to maskBit.
And why is that wrong?
Because the constructor for public reads maskBit and updates it. Then the constructor for private runs, reads the potentially updated maskBit, and updates it again. But this is happening during the constant initialization phase, before the static maskBit1 assignment is guaranteed to be finalized and visible correctly across all these constructor calls. The JLS actually forbids accessing static fields that aren't compile time constants from enum constructors for this reason. You'll likely get a compile error.
Okay, that's the pitfall. So, interview question 4. How do you handle Enum initialization with static members? What's the right way?
The right way is to do any complex initialization that involves static state, especially state that depends on the constants themselves, inside a static initializer block.
The static is
Exactly. That block is guaranteed to run after all the enum constants have been created and the initial static field assignments are done. So the correct modifier example looks like this. Create a public enumeration named modifier with constants public, private, protected, static, final, and abstract. Add a private instance variable named mask. Now, add the static block. Add a static initializer block. Inside the block, create a local int variable named maskBit and assign it 1. Create an enhanced for loop that iterates over each modifier m in the result of calling modifier.values. For each modifier, assign maskBit to m.mask, then multiply maskBit by 2 and assign it back to maskBit.
I see. The static block runs after all modifiers exist, so modifier.values works. And you can safely loop through them and assign the calculated mask to each instance field using the local maskBit counter.
Precisely. The order is constants constructed, static fields initialized, static blocks run. Keep that order in mind.
Good rule. Oh, and a quick side note you mentioned, nested enums.
Right. If you declare an enum inside another class, like class myClass, enum, inner enum, that inner enum is implicitly static. You don't need to write static enum.
Okay, nearly there. One last major area, switch statements. Enums seem tailor-made for them.
Absolutely, they are a perfect fit. Because the set of possible values is fixed and known, the compiler can work really well with enums in switch statements and the newer switch expressions.
Can we use that operation enum again? How would it look in a switch?
Sure. You could write a static helper method using a switch expression. Create an enumeration named operation with constants add, subtract, multiply, and divide. Create a public static method named evol that returns an int and takes 3 parameters, op of typed operation, arg1 of type int, and arg2 of type int. Return the result of a switch expression on op with case add returning arg1 plus arg2, case subtract returning arg1 minus arg2, case multiply returning arg1 times arg2, and case divide returning arg1 divided by arg2.
Nice and clean.
And a key benefit. If your switch covers all the constants of the enum, add, subtract, multiply, divide, you generally don't need a default case. The compiler knows you've handled everything.
Well, that's handy. And if you add a new constant later, say modulo,
the compiler will likely give you an error or warning on that switch, telling you it's no longer exhaustive. It forces you to handle the new case, which prevents bugs. Huge safety feature.
Very cool. And I noticed in the case labels, you just wrote add, not operation.add.
Yeah, that's a nice shorthand. Inside a switch on an enum variable, the compiler infers the enum type, so you can usually use the simple constant name directly. Makes it less verbose.
What if I want to use those simple names outside a switch? Just write small instead of size.small.
You can. You just need a static import at the top of your file. If size is in com.example.demo, you'd write, add a static import statement for all members from the package com.example.demo.size.
Import static com.example.demo.size.
Exactly. Then in your code below that, you can just refer to small, medium, etc. directly. Useful if you use them a lot in one file.
Wow, okay, that was definitely a deep dive. We went from the basic definition and type safety,
through all the standard methods like valueof, values, ordinal,
adding custom data, constructors, the private constructor rule,
that individual behavior per constant, which is super powerful,
the static initialization rules, and how to do it right.
And finally, how nicely they work with switch.
I feel much more prepared to talk about enums now.
Good, that was the goal. Remembering the why behind things, why works, why constructors are private, why ordinal is risky, how static init works, that's what separates a basic answer from a senior level understanding in an interview. Practice explaining them.
Definitely. And here's a final thought to chew on. We saw enums can hold data and have per instance methods. Think about that. They aren't just labels. They can model states in a state machine, where each enum constant represents a state and has methods defining transitions or behavior in that state. Or think about the command pattern. Each enum constant could represent a command, and its execute method performs the action. They're really flexible, type-safe objects hiding in plain sight.
Objects with superpowers, indeed.
So if this deep dive lit up some light bulbs for you, hit that like button and definitely subscribe to the deep dive for more sessions like this. And drop us a comment what other Java areas are giving you trouble in interview prep. We want to know what to tackle next. Thanks so much for tuning in.
Yeah, keep practicing and keep learning.
We'll catch you on the next deep dive.